Welcome back for graphing functions. So up to this point we've learned about the independent and dependent variable. We know what makes a function and why it is a function, and now we're going to practice graphing them. Graphing functions using a given domain. It's giving you a specific value for their input, and the range is the set of corresponding output values, or the y values of the function. One way to understand a function and its features is to graph it. You can graph the function by finding the ordered pairs that satisfy the function, and then using those ordered pairs to plot your points. So we're going to graph the function for the given domain. So our function is x plus 3y equals 15, and our domain is 0, 3, 6, and 9. And remember that the domain, those are your values that you're using for your x or your independent variables. Because we know that our domain is our x values, it's real easy to plug that in and solve for y. So one way to do this is to rearrange how our equation is so that we can get y by itself. So we're going to take our x plus our 3y equals 15, and I'm going to move this x over to the other side. So I'm going to subtract by x, and I'm going to have 3y equals, and because I like the x in front, I'm going to just move down my minus x plus 15, and then to get y by itself, I divide everything by 3. And I'm going to get y equals a negative 1/3 x plus 5. So this is going to be my function that I'm going to use. Okay? So it's going to be my negative 1/3 x plus 5. Alright, so they want us to use the domain of 0, 3, 6, and 9. And so those values are going to come down here in my table, and they become my x values. So 0, 3, 6, and 9, that's my domain. Negative 1/3 times 0 is 0, plus 5 is 5. So my ordered pair is 0, 5. Then I have y equals negative 1/3 times 3 plus 5. If I change that to a fraction, I can simplify. 1 times negative 1 is negative 1. Negative 1 plus 5 is 4. So that means that my ordered pair is 3, 4. My x value is 3. My y value is 4. I can do the same thing with 6. Simplify it. That's negative 2. Negative 2 plus 5 is 3. And so my ordered pair is going to be 6, 3. If x is 9, I'm going to simplify that. That's negative 3. Negative 3 plus 5 is 2. So my ordered pair is going to be 9, 2. And then we're going to graph those. So I have 0, 5. 0, 5. So that'd be about here. 3, 4. So 3, 4, 6, 3, 6, 3, and 9, 2. Okay, so I've graphed my ordered pairs. That's approximately what they are. Is this a function? Yes, it is. If I do a vertical line test, I have only one input for every output, or one output for every input. Set it backwards. We can also graph when we're using domain of all real numbers. If the domain of a function is all real numbers, any number can be used as input value, producing an infinite number of ordered pairs that satisfy the function. We can't come up with every answer because we're talking about an infinite number or a very large number of possibilities to use for our domain. So when we're talking about doing something like this, and we know that it seems to be working with every number, we can create a line by adding arrowheads at both ends of a smooth line or curve to represent the infinite number of ordered pairs. And we saw that when we were determining if it is a function or not, and looking for the domain and range on graphs much earlier in our lessons. If a domain is not provided, it should be assumed that the domain is all real numbers. So in cases like this, if they don't tell us what the domain is, or if they don't give us a reasonable number to work towards, then we can assume that it's all real numbers. So when we're graphing these, when we're using the domain of all real numbers, we're going to use the function to generate ordered pairs by choosing several values for x. And then we're going to plot just enough points to see a pattern for the graph, and then connect the points. And that's either going to be a straight line or it could be a smooth curve, okay? So our first example that we're going to be working with is y equals x squared. And you'll notice that the domain that we're using, or the values for our input, are -3, -2, -1, 0, 1, 2, and 3. And we do this so that we can get a nice general idea across the entire graph of what's happening. And so when I plug -3 into my y equals x squared, -3 times -3 is a positive 9. So I'm going to get the ordered pair -3, 9. -2 squared is positive 4. I get -2, 4. And then you'll notice that as we go down, we're starting to notice that there's a repeat. It's kind of almost mirror image, isn't it? Y's are 1s, Y's are 4s, Y's are 9s. When we do that and we plot our points, we're seeing that our points are mirroring each other, with 0, 0 being the only one that's not repeated. And so when that happens, we just put arrowheads on the ends, because it's showing us that it's going to continue to keep going up, and it's got this nice curve to it. If I have the function of x is 3x minus 5, and I've picked just a general order of ordered pairs, I have, input values, sorry about that. So I have -1, 0, 1, 2, 3, 4. And so they want me to solve to find out what my function is, or my y value. So if x is -1, that's -3. -3 minus 5 is -8. And so it's going to be 1, -8, or -1, -8. If my function is 0, where x is 0, 3 times 0 is 0, minus 5 is -5. So my ordered pair is 0, -5. If x is 1, I'm going to substitute 1 in for my x's. 3 times 1 is 3. 3 minus 5 is -2. So my ordered pair is 1, -2. If x is 2, 3 times 2 is 6. 6 minus 5 is 1. So my ordered pair is going to be 2, 1. If x is 3, I'm substituting in 3. 3 times 3 is 9. 9 minus 5 is 4. So my ordered pair is 3, 4. And my last one I have here is if x is 4, I'm substituting in for 4. 3 times 4 is 12. 12 minus 5 is 7. So my ordered pair is going to be 4 and 7. And now we're going to plot these points. So here I've plotted all those ordered pairs. And if I were to draw through them, let's see, let's get a solid line in blue. And we notice that it creates a straight line. So what I'm going to do now is to put arrowheads on the ends of them, and to represent that it's all real numbers. The points appear to form a line. So we're going to draw a line through all of the points shown, that they're going to show that these ordered pairs satisfy the function. And then we're going to draw arrowheads on both ends of the graph. So I'm just going to put arrows. So you're going to draw arrows. Okay? So we're going to graph each function. So we need to have some values for our x's and our values for our y's. Because it is negative, we're just going to need to be very careful. So I'm going to use -2, -1, 0, 1, and 2. If I have this is the same thing as the opposite, or -1 times whatever my x is squared. So -2 squared is 4. 4 times -1 is -4. -1 squared is 1. 1 times -1 is -1. 0 squared is 0. 0 times -1 is 0. 1 squared is 1. 1 times -1 is -1. 2 squared is 4. 4 times -1 is -4. So now I have some that I can graph. I have -2, -4. So -2, -4. -1, -1. Halfway, halfway. Probably about there. 0, 0. 1, -1. And 2, -4. And so what you notice is that it's mirroring across the y. So we have, these are not as easy to draw. Okay, and I have my arrows. So this is what -x squared looks like when it's plotted. Okay, do the same thing to number 5. And if you have any questions, make sure you ask your teacher. We're going to go on to the your turn number 7. A cruise ship is currently 5 kilometers away from its port and is traveling away from the port at 15 kilometers per hour. The function y equals 15x plus 5 relates to the number of kilometers y the ship will be from the port in x number of hours from now. How far will the cruise ship be from its port 2.5 hours from now? And when you think about these, remember when we were talking about reasonable domain, that we talked about the fact that the value for x has to be something that makes sense. And we can't go negative number of hours. So we're going to start with 0, 1, 2, and 3. Okay? So these are going to be reasonable numbers. Then we're going to plot these, plug these in. So we're going to have 15 times 0 is 0 plus 5 is 5. And we have 15 times 1 is 15 plus 5 is 20. So we'll have 120. And then we have 15 times 2, which is 30. 30 plus 5 is 35. And then we have for 3 hours, it's 45 plus 5 is 50. Okay, now we're ready to plot those ordered pairs. So 0, 5, 120, 235, 350. And so when I connect my dots, oops, let's try it this way. What are we noticing? It's creating a straight line, isn't it? So we're going to put our arrow on the end of it. So in this case, it's not all real numbers, but is all whole numbers. So our domain is greater than 0, and then our range is numbers that y is greater than or equal to 5. Okay. Okay, there's some extra ones here that you can practice. If you have any questions, make sure you talk to me. Thank you.